Okay, we start.
Yeah, sure. But just give me 1 sec.
Yeah, maybe before, can you share your screen, Pak Sandes? Try
Yes,
to
I'm
share.
doing that.
Yeah, just trying first.
Share. Let me know if you're able to see
Okay.
this.
Yes, we can share, see your screen, Pak.
Great.
Okay.
So,
Yeah, let me open first, then you can continue to present.
sure,
Okay.
sure.
Okay, thank you so much, everybody, for joining this session. So let me introduce myself first. I'm Abdul Ghani, Abdul Ghani Fataifur. Now I'm based in Japan, working for Rakuten Mobile. In this opportunity, I will help Pak Sandes become a moderator for today's session. Just for your information, today's session we will talking about Open RAN and vRAN, and what is the introduction and anything related to the vRAN. So in this today's meeting sharing session, approximately the duration will be 1 hour and 30 minutes. And then if you have some question, please write down your question first in the chat box, and then I will compile the your question. And then if the time is enough, we will start discussing about your question. And then if still if there is another time, so we can maybe you can open your mic, and then we can start a discussion. Maybe this is our rundown for tonight. Before going further, I would like to introduce the background Pak Sandes. Pak Sandes, wait, Sandes. Okay, Pak Sandes currently working in VMware as business development manager for Open RAN and 5G. And then Pak Sandes already have around 17 years plus experience in telecommunication industry. So this is very good time if you have a lot of question regarding to related to the telecommunication. Please explore your question as much as you can. And then beside that, before working in VMware, Pak Sandes also working for Nokia for a long time. During his employment in Nokia, he have been holding position like head of network planning for APG Nokia Indonesia, and then also LTE SME in Nokia Canada. And most of the time, maybe Pak Sandes working for LTE optimization lead for GDC Indonesia. Me and Pak Sandes also working together when we are working in GDC Indonesia. He is very expert. So yeah, maybe directly I will give a place. I will give the stage to Pak Sandes to explain about our topic today. Please, Pak Sandes.
Thank you, Pagoni. And hello, everyone. I hope you're doing good. And it feels good to come out of this pandemic. I think hopefully we'll have personal interactions as well. Yeah. So on this note, and as Pagoni said, that whenever you have any questions in this regards or in the session, please put them in the chat. Please be interactive. Try to contribute. I would like to keep it as light in terms of the mood as possible. It is more of sharing of the ORAN and vRAN. And along with that, I will also share some of my personal experiences, why I moved to this specific field from career point of view. And then maybe later on, I'll also speak as to why I choose VMware as my employer. Yeah. So during this. So without further ado, let's start today's session here. So this is the agenda, not necessarily everything is exactly in this order, but this is just a structure that we're going to use in today's session. We're going through the terminologies, the standard, the history of ORAN, the working group, its architecture, its functions. So we'll go a bit details into the technical side of it. As I understand, most of us here are on the technical RAN side, right? And then we'll talk about the challenges and the targets. Yeah. So first of all, why? So we hear a lot of terms about ORAN and Open RAN, and is it all the same? So let's first clarify that one. Yeah. So primarily, I categorize that into three different words. So one is open space RAN, other is O-RAN, and the third one is Open RAN. So these three things identify three different things. These three words identify three different things. First is the open space RAN is referred to the disaggregation of RAN functionality. So which is based on the open interface specification between the elements. It can be vendor neutral hardware or software, or it can be defined in vendor specific hardware. So it doesn't have to be specifically coming from a a virtualized environment, and this refers to the ORAN standard. Now, O-RAN refers to the designated alliance, the ORAN alliance, or its specification. So whenever you see O-RAN, it's either talking about the ORAN alliance, which is the group that is specifying the ORAN's standards, or its specifications itself. Okay, and then there is ORAN together. So it represents either one of the two things. One, it could represent one of the two group in TIP, the Telecom Infra Project. So Telecom Infra Project group, Telecom Infra Project is an initiative started by Facebook, and it is started to foster the open ecosystem in RAN. Now, it has two working groups inside it that are referred by Open RAN, the Open RAN project group, and the Open RAN 5G NR project group. The Open RAN together is also used as a hashtag whenever we are talking on social media about ORAN. These are the three different words. They mean three different things. So just to get everybody accustomed with the lingo, yeah. Okay, now before we go into ORAN and trying to understand what that is, let's first understand what is the current radio network look like. So the current radio network is a closed system wherein we have everything inside one black box. We don't know how the inside of it is made. We have a baseband unit, which is a vendor specific hardware, and then it is connected to a radio unit, again a vendor specific hardware, and running on a vendor specific software. Now this ecosystem is mostly dominated by three main players. There are I mean it's mostly three. There are few more other players in the market as well. Now what has happened with this is that this has become a pretty closed system, and with that the innovation has been very slow, and this is the frustration that most of the operators were having. So because of the low innovation, and the operators were not able to utilize this to their benefit. Also, the cost was not very competitive because the market was pretty dominated by these three, and there was hardly any programmability inside this RAN. So the operators were getting increasingly frustrated with this, and they thought they should change this, and that's why ORAN came into existence. And then the other factors that were pushing for ORAN was that especially with 5G, we could see that from 2G to 4G, most of the experience of the network and most of the experience running the networks have been pretty much the same. But then the operators' revenue was consistently declining. So there was a need for the operators to find new business models to be able to make more revenue out of the existing networks or the future networks that they're going to build, like 5G, right? The second challenge was most of the architecture was divided into silos. We had RAN, we had core, and there was hardly anything interacting between the two, and this was slowing down the plans for modernization. So it was very difficult to modernize throughout the network. Uh, the third challenge was that there was no agility and flexibility. What I mean by that is that, for example, if you want to upgrade to a new version, it was a very painstaking process. We all know, I think most of us have been in RF, right? Software upgrades were very painful. Even if you request a feature to a specific vendor, it will take a lot of time, maybe 6 to 12 months to get a feature request approved, right? So this was something that was a very painful process. And then so suppose if you're not a very big operator, or if you're not very important for the vendor, they might not prioritize your feature requests or upgrade requests. So that was one of the challenges that operators have. And lastly, the operations were pretty complex. We have seen, right, there were huge knocks, and managing these networks was very, very complicated. So they wanted to simplify all of this, and that's how the operators came together to establish the ORAN forum. Okay, but then the question arises that we already have 3GPP, right? And 3GPP is pretty much open. So why we need ORAN in the first place? So 3GPP does define some sort of interfaces, and they are not very, and there a lot of them are implementation dependent. So it doesn't really address the problem of openness. Apart from that, the RAN itself was monolithic. So it was more of a three vendor dominated market. And this was something that was impacting the innovation, as I said before, right? So there were two different forums that were working, and they came together to define the open and disaggregated RAN. So by disaggregated means they tried to break down the baseband into different units and define how these separate units would work together. And lastly, to make use of agile and flexible architecture, virtualization was introduced. So it was introduced that this should be virtualized so that it becomes more agile, and also it addressed the complexities of running on the multi-vendor platform. All of this was targeted at one primary thing, that was reducing the capex and opex for the operators, and ensuring that they have new business models so that they can have more revenue out of it, and they have more players, more competition in the market, and there should be faster innovation so that there would be more contributors to the RAN ecosystem. Okay, so with that aspect, sorry, what's happening? Okay, so now let's look at how Open RAN is different from the previous closed black box RAN that I was referring to. So previously we had a baseband unit. Now the baseband unit is split into a DU, a CU, and a RIC. Okay, and then we have an open front haul that is connecting them. It is not running on a black box, but it is an open box wherein or a white box, where we have a vendor neutral hardware running on top of a running on top that is a software, and the management plane is now extended until the core network. Okay, so this is in a higher sense what the RAN disaggregation wanted to target. So basically take the baseband unit, split it into components, define the interfaces between them, and then open up the ecosystem for most of the players. And along with that, they introduced this RIC, which is an additional functionality which adds the AI/ML capabilities to the RAN ecosystem. Okay, so with this in view, there were two different groups working on similar standards for openness. One was called the XRAN forum, which was primarily between NTT Docomo and some of the European and American operators. And the second one was a CRAN forum, mostly with China Mobile and IBM and few other contributors for the Cloud RAN, as it used to be called then. So these two forums merged together to form ORAN Alliance in 2018, and in 2020 February, the ORAN Alliance was merged into TIP, not merged but collaborated with TIP. Okay, so there are 9 working groups, actually 10 now. There has been an additional working group now. So there are 10 working groups, and there are, I think right now, about 27 plus operators and 220 plus members companies of ORAN. This number is growing. At this point, I would like to share a personal story from my end. In I think it was October or November of 2000. It was October 2018. I was working in Nokia Canada, and I was reading about ORAN, and I felt really excited, and I thought I need to explore. So I went to a TIP summit in 2018 in London. And what I saw there was something that changed the rest of the course of my career. So I saw that there was a lot of movement happening on open standards. I went to a parallel wireless booth where they had a very small box which was running 2G, 3G, LTE on an off-the-shelf hardware and completely software oriented implementation. And I realized that this is going to be the future of telecom, because what we were delivering would not be able to cope up with this new thing that is coming. And that's how I started exploring this. In the same forum, in the TIP Summit, I got to hear a lot of great people who told the backstory of why they were really frustrated with most of the vendors. One of the Vodafone executive said that because of this closed system, they are pretty much cornered into what they get out of their investments into RAN. And RAN being about 70% of an operator's spending, they wanted more flexibilities, more player, more innovation, and openness, so that they should be able to try and mix the best of what they think or whatever they find good. Yeah. So with that in mind, this forum was established, and that's also the short background of why I went into Open RAN. So since then, I've been exploring this. Sorry, it's summer in India. It's pretty hot, yeah. So okay. So the Open RAN came together in 2018 with fixed objectives. So one was that they wanted to adapt open interfaces and infrastructure to allow multi-vendor combinations inside the RAN. The primary objective was they wanted to decrease the total cost of ownership and increase competition with a white box approach, so that there will be more players, and the cost would go down with generic hardware and software functionalities. They also want to promote rapid industry adoption of these interfaces and APIs, so that more and more players would come on board on the ORAN Alliance. And they wanted to add RAN programmability for the service optimization. I think this is something I, especially coming from the RAN optimization background, feels very connected to. And I have seen a lot of very skilled colleagues, especially in Indonesia. As Pagoni was saying, during the GDC days, there were a lot of people who were very good at programming, but it was just that there was a lot of limitation of what we could get out of the system. Operators also felt the same. They wanted to improve that, and they proposed a RAN programmability aspect in the ORAN. And also they wanted to have a faster time to react to market. So faster, they wanted to go quickly. So for example, they don't want to wait 6 months for an upgrade cycle. If they want something specifically, they should be able to upgrade very, very fast. So the ORAN Alliance, this is how it is structured. It's structured into 10 working groups that are working on a very specific aspect of the ORAN specification and architecture. So starting with the use cases and the overall architecture, the RIC, and then going all the way up to the O&M work group. We in VMware, I think, are part of work group 1, which is the overall use cases and architecture, the non-real-time RIC, the real-time RIC, the cloudification and orchestration, and the O&M O&A work group. To the best of my knowledge, I am not very sure, but I think, yeah, we are part of these 4 groups. Okay, then let's look into how the architecture looks like, yeah, for ORAN. So ORAN specifies an architecture which says that we are on top, we have a service management and orchestration layer, which is taking care of the management of all the elements inside the RAN. Then, if you remember, the baseband was split into 3 separate components. One is the CU, which is a centralized unit. Then we have a DU, which is a distributed unit, which is connected by open front hall to a radio unit and a RAN intelligence controller. So this is an optional functionality defined by ORAN to add intelligence and programmability to the RAN. And then it defines all of these interfaces between these elements. So later on, we'll go in detail also of what this interfaces look like. So let's look into detail of how the architecture looks like. Yeah. So if I start from below, we have the RU, where we have the physical or the low-fi as it is called, and it is connected by the open front hall to the DU, where it runs the high part of the physical layer, the MAC and the RLC. And then it is connected via mid-hall interface F1 to the CU, where the RRC and the PDCP is run, or the SDAP for the user plane. The ORAN Alliance defines this architecture to be running, so the CU and top to be running on virtualized layer on top of a CTOS hardware. So CTOS is commercial off the shelf, so something that you can buy commercially in any vendor. So maybe any board that you can buy, any Intel board or anything that you can buy off the shelf, and then all of these components running as software on top of it. Now, on top of this is the RIC. So the RIC is split into 2 functionalities. One is called a real-time, near real-time RIC, and then the non-real-time RIC. So the near real-time RIC is running the time-critical functions of RAN. So like the radio connection management, mobility management, QoS management, so all of this. The best part of this is that with near real-time RIC's functionality, the operators would be able to tune and even buy. So this would be like an app store called the X apps, and you would be able to run these applications on top of this RIC. So, for example, if a company comes up with an algorithm of a better algorithm of amplitude modulation encoding scheme, you would be able to implement that in your network. You don't have to wait for the vendor to come up with an algorithm. Or we have a lot of good programmers in the RAN ecosystem. I've seen it firsthand. They would be able to utilize the APIs available and write their own code of how they want each of the algorithm to behave. So, for example, say load balancing. Right now, there are a lot of people who would be able to put together a logic of how the load balancing should work, and then it can be implemented as an app in here, and the load balancing would automatically happen. Okay, rather than defining the parameters, you could define the logic of how it has to work. Okay. Then it is connected to the orchestration and management layer, also known as SMO or SMO, and it is responsible for the design, inventory, policy, and configuration management of all of these. And it also houses the non-real-time RIC component of the architecture. Okay. So this is how the ORAN architecture specifies the RAN to look like, and this is how most of the implementations have also been. Okay, so yeah, one part of it is that RIC is a fairly new addition to the RAN ORAN specification. It is currently being most of that is currently being built. What we have mostly is the non-real-time RIC. The real-time RIC, I think the specifications are being discussed and finalized, and we would see in probably very soon the real-time RIC products as well. Okay, now let's talk about the interfaces and that I was showing previously, and the functionalities. Yeah, so there are three type of interfaces here. One is this black one or the dark gray one, which are the 3GPP specified interfaces. So we are just using, or ORAN is just reusing those. Then there are these green, which are ORAN specified interfaces, and then there is just one of these which is for further study. So let's start from the ORAN specified one, yeah, because I think 3GPP everybody knows. We know X2, we know XN, we know NG interfaces, and we know F1. So which is the mid haul. So let's start with the ORAN interfaces. So first of all is the O1 interface. So O1 is where the SMO or the SMO, the Service Management and Orchestration Framework, connects to every element in the architecture for the element operation and management. Okay, so this will connect to the RIC, the CU, the DU, and there is also and further exploration ongoing that should it connect to the RU as well. Okay, then we have the O2 interface, wherein the SMO is connected to the O cloud. So O cloud is where most of the infrastructure would reside. Then we have A1 interface. It's called the intent-based interface, which connects the non-real-time RIC to the real-time RIC. So one important thing to realize is that the non-real-time RIC is connected to the rest of the RAN infrastructure only through the A1 interface. That's why near real-time RIC is very important. And then this near real-time RIC is connected to every other element in the ORAN architecture using a E2 interface. And this E2 interface is mostly for data collection and actions to be done by the rest. So for example, it's connected to the CU, the DU, and the OE node B via E2 interface. Now the DU and the RU are connected by the open front haul. ECPRI 7.2 is the choice of open front haul for ORAN. So that is where the CU and DU is connected. And then the rest of that, these black ones are the 3GPP interfaces. Okay, so that's how the interfaces for ORAN looks like. Okay, now moving to my favorite part of ORAN Alliance architecture, yeah. So which is the real-time RIC, the near real-time RIC or the RAN intelligence controller in detail. So if you look at, this is the specification coming from the ORAN Alliance of how the RAN intelligence controller near real-time implementation should look like. So the E2 nodes, here T nodes, the CU, DU, and maybe OG node Bs that might be there. And this is the architecture of how it would look like. As I said, it would have X apps running on top of it. And these X apps could come from different vendors. So there could be a small company who would be very good at doing only one part of RAN, and they could come up with, say, interference mitigation algorithm. They would be just selling that. So that is the beauty of ORAN, that we would be able to buy that and install. The operators would be able to customize what they want to go inside their network, and this could be very operator specific implementations. Yeah? So let's look at how the structure or the architecture look like. So we have a messaging infrastructure which connects all the components of the near real-time RIC. Then we have a conflict management. So why we need a conflict management is, suppose that there are multiple apps that want to do the same thing, the conflict management is the one that would decide what should get implemented in the network. Subscription management is something that enables the X apps to have the access to the underlying data layer and the databases. Management services basically means like the OSS, the fault management, configuration management, performance management that would come here. Then security in terms of how the apps are secured for not having or not being able to not allow them to do something that they're not supposed to do. The AI ML support, so that the apps would be able to utilize the inbuilt AI ML functionalities of the rig, and then the repository for A1 specific routings. Then there is also the API enablement. So this would enable the programmability from even the outside of the network for the rig. So this kind of this would enable like use cases like the end-to-end network slicing. Okay, so this is how the near real-time rig is envisioned in the ORAN alliance. Just give me one more. Sorry. Okay, now this is how the non-real-time rig framework looks like as specified by the ORAN alliance. So we have an A1 interface, as I mentioned, in between the near real-time rig and the non-real-time rig. So everything that the non-real-time rig has to do has to go through the A1 interface. Even the data is collected from the A1 interface, and even the actions are pushed down from the non-real-time rig to the real-time rig using the A1 interface. It would also host apps which are called RApps. They are non-time critical apps, and where we would see more use case specific implementations. And also it would have these AIML workflows that would take use of all the data that is available, and then would have some inbuilt functions that can be used by these apps. Okay, so we have all of this done. So what do we expect, or what the ORAN Alliance expect to get out of this? One is that significant reduction in the OPEX, because we have now an automation and intelligence available, so we could minimize the repetitive manual task and improve our efficiency of the network, and even our teams as well. Significant reduction in capex because we'll have more wider choice of vendors available, and more competition would be there in the market. Third is we want to increase the agility by having this programmability available, and having it implemented in software would make it more agile, and the operators would be able to respond to the market faster. And lastly, because of the open APIs, we would have a wider ecosystem available that would drive innovation in the overall RAN, which has been stalled mostly until now, until we had ORAN specification. So this is what the ORAN benefits would be. Okay. Now, if at this point I say that's about it, you would say, wait a minute, what about vRAN then, right? So until now we were talking about ORAN. Now let's talk about what vRAN is. Okay, so we will go into the details of what vRAN is, what are the basics of cloud, what is cloud native, how the vRAN deployment would look like, what are the benefits of having vRAN, and then let's look into also the aspect of, is this only on PowerPoint, or is this really getting implemented somewhere? What is the reality of this technology? And lastly, Pagoni requested me to share what would be what is VMware's RAN and telco product looks like. Okay, so what VMware has to do with all of this. Maybe there I would share some some personal part of my story that why I went into VMware. Okay, so until now we were talking about ORAN, and now we wanted to discuss about vRAN, and these two are completely different things. ORAN doesn't have to be virtualized. So vRAN refers to virtualized RAN, or RAN that is implemented on off-the-shelf hardware running on top, and running on top of that is a software. So the ORAN doesn't have to be implemented in a virtualized network. We have ORAN being implemented in a classical hardware as well, and this is happening. So ORAN basically means we have a horizontal openness between the components, and we have an open interface to connect these components. So we take one box, we split it into functionalities, we define how it connects, and that is what ORAN is about. But vRAN is getting inside that box, splitting that box vertically into hardware, software, and a virtualization layer. So vRAN means getting inside of each of the CU and DU, and then splitting the hardware and the software and making them independent of each other. So that is what vRAN is. So in short, ORAN is the horizontal disaggregation, and vRAN is the vertical disaggregation inside that, inside each of these boxes. Okay, so and then ORAN's main target is that it wants to be multi-vendor. vRAN's target is that it has to be cloudified. It doesn't have to be a multi-vendor always. Okay, so we have single vendor implementations of vRAN as well. Okay, so before we go to cloud and cloud native software, I thought it's better to discuss what virtualization is and what cloud is, and what are the difference between those two. Yeah. So virtualization doesn't mean cloud. So virtualization is the technology that makes cloud computing work, but virtualization is not cloud. So virtualization means that you virtualize, so you augment the hardware into a software, and then you can run any application on top of it. But that doesn't mean cloud. And for smaller companies, maybe virtualization is easier and more cost effective. And as I said, virtualization and cloud are not interchangeable with each other. So let's talk about cloud, or what constitutes to be a cloud. So cloud means that something that is on demand and self-service. So a consumer is able to unilaterally provision the computing, the networking, the storage, whatever he wants, should be able to do that on demand. It also means resource pooling. So we have computing resource pooled together in a multi-tenant model. That is what cloud represents. And it also represents measured service. So automatically control of and optimization of how many resources being used by whom. And then it has a broad access in terms of clients and devices. So anybody from any client should be able to connect with that. That's what cloud represents. And the most important, it has rapid elasticity. So the user should be able to reduce and grow the capacity through software. This is all constitutes as a cloud. I think we all are aware of these three cloud service or cloud consumption model. The SaaS, which is the software as a service, wherein a consumer can use a software that is running on top of a cloud infrastructure. So we are only consuming the application running on top of the cloud infrastructure. In platform as a service, the consumer can deploy the cloud infrastructure applications created using whatever the programming or libraries that are available. So it is more about the consuming the infrastructure. And then the infrastructure as a service is wherein the consumer can provision however infrastructure he needs based through software. So through programming, it can configure how much processing, storage, network it needs. So that is infrastructure as a service. So it's basically going down further into details of the virtualization. Yeah. Now there are four different models of deployment of a cloud that currently exists. So one is the private cloud. One is the private cloud. So private cloud is an infrastructure that is provisioned for exclusive use by a single organization. And it has multiple consumer inside. So for example, most of the operators have a private cloud nowadays for their core network. So most of the core is currently run as a virtualized network function, and it is running on top of their own cloud infrastructure. Then we have community clouds, wherein it is the cloud infrastructure is meant to be consumed by a specific group. So for example, a college has a cloud, it would be termed as a community cloud. Then there is public cloud, which is open for general use, like AWS, Azure, Google. All of these are public clouds. And then the last is a hybrid cloud. So hybrid cloud is a combination of any of the three. You could have private and public, or private and community, or whatever. Mostly you would have private and public cloud combination, where either because of security or regulatory reasons, some of the workloads cannot be deployed on public cloud and they have to be on the private cloud. So for example, I think as far as I know, the regulations in Indonesia won't allow the core to be deployed on a public cloud. It has to be on a private cloud inside Indonesia. So those are some of the ways it is deployed. So now we understand what cloud is. Let's try to understand what a cloud native technology or an application means. So there are a lot of definitions of what is cloud native. For me, I think this is definition that makes a lot more sense to me. I copied this from Kube Academy. It's a free resource available. You can Google Kube Academy from VMware. It has a very good resources available for you to study about Kubernetes and cloud native architecture and technologies. So you can go to search Kube Academy and register and learn about this. Yeah. So for me, I think a cloud native application has four main characteristics. One is it has DevOps. So there is a common goal between the development team and the operations team, because they are always in conflict of what has to be achieved. And then the second part of the DevOps is that you should be able to manage the infrastructure as a code. So what does that mean is that you should be able to provision whatever infrastructure you need through code, through programming. The second key component is CI/CD pipeline. So you should always be shipping new code. So it has to be a continuous cycle of deployments. Third is to have a microservices based architecture. And what does mean is that a big application is grouped into small, loosely coupled microservices, and that way the deployment could be faster. And lastly, and very important, is that all the applications are containerized. So they are deployed as containers on top of the infrastructure. Okay, so these four constitutes to be a cloud native application. And then when we talk about vRAN, what does that mean is that all of the CUs and the DUs has to be cloud native in terms of their implementation. Not everything, but at least whatever is implemented in cloud has to be cloud native. Then only we would call that as to be virtualized RAN or vRAN. So there are four different ways vRAN can be implemented. So one is that when we call it distributed RAN, or this is how currently most of the RAN looks like. We have both the CUs and DU located at the cell site or far edge location. I think the most popular, however, that would become probably in the near future would be this distributed DU and centralized CU implementation, wherein the CU would be in in an aggregated site running maybe in a cloud environment, and then the DU would be at the sale site. So it could be on-prem or it could still be on cloud, but it would be at the sale site. I think Pagoni might be aware of this. Yeah, I think Rakuten is in the second category.
In the second and third category. Actually, we have everything, Pak.
Oh yeah. Your 5G
Yes.
is in the third category, right? Yeah, it's
Yeah,
Cloud
yeah.
RAN. Yeah. And then there is Cloud RAN, which is the holy grail. Yeah, we have everything running in the cloud, and then it's only connected to the radio unit, which is on site. Okay, and then there could be hybrid. I think Rakuten is in the hybrid category, where we have some of it is running in the distributed DU, and some of it is all cloudified RAN, and all of this is connected to the core, which is again running in the cloud, either as virtualized network functions or containerized network functions running on top of a cloud infrastructure. Okay, so this is what vRAN would look like. And so now if we want to address that, why we have to do, why should we move the RAN to cloud? What is the advantage of moving the RAN to cloud? We've seen the advantage of having an open ecosystem or open architecture. Now let's look at the other part of it, that what would happen if we move the RAN to the cloud. So when we move the RAN, it would become very modular, so very easy to scale, and very easy to optimize as well in terms of resources. So for example, we could have on-demand spinning up of CUs and DUs. That is possible. Okay, we will have AI and ML capabilities that are already available in the cloud that the RAN can utilize, and then it would make the RAN very modular, so that we could then utilize the modularity to our advantage of making separate between the CU and the DU. Then monetization of RAN. So this would help drive new use cases, and that would help the operators have further growth in their revenue. This would happen because we would have more innovation. That could happen because everything is loosely coupled. We could have a lot of players coming up as apps, and then lastly, we could have dynamic provisioning of new service offering. So we could dynamically provision everything. It doesn't have to be very statically defined as it is currently done. And lastly, I think this is the power of choice, wherein it would be multi-vendor implementations, and you could get best of breed. What I mean by best of breed is you could get the best hardware that you want, the best CU software that's useful for you, and the best DU software that you could take. This could come from all of this could come from different vendors, and you could put together a system that would work. This is the power of open and virtualized RAN, and I think that's why I feel that this is the future of the RAN that we're going to look at. Now we all talked about open and virtualized RAN, but the path is not really that easy. There are a lot of challenges because the cloud is new to RAN, the RAN is new to cloud. We have multi-cloud management, we have real-time workloads because DU is very time sensitive. Then there is security aspects. There are a lot of other things. For example, the organizations are not currently structured in a way where we could utilize most of this. The multi-vendor implementations of CUs, DUs make it very difficult. We have to ensure that the interworking happens. But apart from all of this, there has been tremendous progress in ORAN, vRAN, especially in the last few years. There has been tremendous progress in this field, and this has come from specifications now to actual implementations. And just this Mobile World Congress, that just happened start of this month, I think. Yeah, start of this month, we had Mobile World Congress in Barcelona. There are 40 plus operators in it that are currently having an ongoing trial or a deployment across the globe for ORAN right now, and which is fantastic. You could see that there's a lot of interest in this technology, and that's why I say that this is what I feel is the technology of future. This is what it's going to be in the near future. Everything would be open, virtualized, deployed on a cloud, most probably would be a hybrid cloud. And that's how I see the future of networks would look like. Okay, so now let's move to what VMware has to offer to all of this. Why? I mean, what VMware has to do with all of these, with telco, with virtualization, with RAN. So VMware has a multi-cloud strategy. What does that mean? Is that you could run any application on any cloud. You could build, run, manage, connect, protect any application on any cloud, be it Azure, AWS, our own cloud, Google Cloud, Alibaba, IBM, Oracle, whatever you want, we could run and manage that application for you. What does that has to offer? It simplifies the operation tremendously, because then you have a consistent platform running across from your core to the RAN that you could use to manage the whole infrastructure. So you don't have to have 10 different things, and we have seen this challenge, right? So maybe first let me map how the portfolio looks like. Yeah, so we have a telco cloud platform for RAN, which is this OCloud, and then we have a RIC portfolio, and this is where we could host third-party CU and DU apps running on the virtualized platform. Below it could be any infrastructure, it could be any cloud, private, public, hybrid, whatever. We would be able to deliver consistently across. And what I mean, and probably one of the reason why I decided to explore the career opportunities with VMware was that they are the only provider who had a consistent platform across from the core to the RAD, even to the public cloud, the enterprise edge. Everything would be running on a single cloud. We have seen this pain, especially me coming from the RAN background, have seen that if there is a core counter mismatch, it is literally impossible in the current state to find out unless things goes wrong, and it would take immense effort to correct it. So for example, if some of the timers in the core are not set according to what has been set on the RAN side, we would have a lot of problems on the RAN side, and it would take immense effort to first find out what is going wrong in the core side. What I found fascinating with the telco cloud platform from VMware is that it is a consistent platform across from the core to the RAN. So you would have one plane, so you would have one interface where you could configure your VNFs, core RAN, your provider edge sites. So provider edge means whoever is your cloud provider for your edge, be it your own public cloud, be it your own private cloud, or it could be AWS, Google, or whatever. It could be that, and then your RAN. Everything can be controlled, managed, orchestrated, automate through one platform, and I think this is extremely powerful, and that's why I feel that VMware has a very strong portfolio, and I should be there. So just to show you how it would look like, so imagine the cloud sites, the core, the regional data centers, the near edge, everything running with its own apps, containerized network functions. Be it the RIC or your DRIC, which is distributed at the edge, the the provider edge, which is your cloud platform provider, be it public or your own, and even the RAN sites where the DU is running, or even the mobile edge. So all of this could run on a single platform, and this is very powerful, and this is very unique. And this is why I feel that VMware is very well positioned for this. So this is what VMware has to offer to the ecosystem. One consistent platform. You could choose any RAN vendor. You could have Altiostar, Mavenir, whatever you want. Uh, you could run it on any cloud. You could run it on AWS, Google. You could run it on your own cloud, and all of this could be put together in one single operation. That way, it simplifies your operation, automation. Everything becomes very simple with this. That is the plus point of VMware. So how do we see the journey today? So we've seen a lot of vRAN implementations right now happening. There are a lot of vendors who are deploying Cloud RAN. Now it's going to go towards most of the open interfaces and ORAN compliant implementations. That is how the future of the network is going to look like: open, disaggregated, and cloudified. That is how I could summarize the implementation. Yeah. And then if we look into what the TCP RAN would have to offer, so we would have an infrastructure. So we would have a virtualization layer. On top of that, we would have our Kubernetes. We call this container as a service, and running on top of that is our automation platform. And you could deploy any RAN functions, as I said, and any 5G applications on top of this. So this is what VMware has to offer to RAN as an ecosystem. Yeah. Now let's move on to questions and answers. And actually, I have asked Pagodi if there are any questions before the session, and he has sent me a few of them. So I've put them down. I think maybe we can go through them first, if that's okay, Pagoni.
Yes, Pak. Okay. So there is already have a question here from Dewi. Okay, so maybe Pak Sandes already explained about the virtualization versus cloud. So in your slide, mentioned that virtualization is not equal with the cloud, but virtualization is like the small foundation for the cloud. Can you please elaborate more, Pak Sandes?
Yeah, so virtualization means that we have one hardware. So how virtualization was born, maybe I can explain out of that. Was so previously, when a lot of companies wanted applications to deploy on their servers, so they were buying a lot of hardware for different applications, and all of that hardware was mostly bought over provision. By over provision means that you will buy a CPU, hard disk, and network that you are going to need for maybe next 3 to 5 years, right? And then these separate boxes were lying in one organization, and most of them were underutilized. So the CPU utilization, or the hardware, the hard disk utilization of most of them would be maybe even less than 10-20%. That is because you want to plan for the future. So most of the organizations realize that they are actually over provisioning or over buying for their need, and then there are these different hardwares, and we cannot make use of them. So that's how VMware was born. So VMware was born out of virtualizing the existing hardware. So what it does is that you have, so basically a hardware means a compute resource, a storage, and a networking resource. Now VMware puts on top of that a virtualization layer which separates this compute, storage, and network into small separate groups, and you can have applications running on top of it. So now you don't have to buy 10 different hardware. What you can do is buy one big hardware and then separate it by virtualization to run separate applications. Now, for us to have a programmable access to the infrastructure, virtualization is important. So for example, when I say that cloud has to have elasticity, or cloud infrastructure should be able to provision on the go, on the fly, any compute or storage resources, say in the infrastructure as a service option. It can only be done if we have virtualization below it, because then you would be programmably able to add or remove the components that you need. So you would be programmably able to add compute or storage or networking as it is needed um, by the requirement. And that's why it is very important for the cloud to have virtualization. So it's an essential component for cloudification.
I think very comprehensive explanation. What do you think, Mbak Dewi? If you have another question, you can ask more, or you can open your mic. It's fine. I think we
Yeah.
have plenty time.
And I see that there was something. Ya, kalau
Yeah,
dalam bahasa Indonesia juga gak apa-apa ya.
I
Tadi
try to translate. Maybe there is another question, Pak Sandes here. How long the operator, if you want to migrate to the open from traditional to open run, so how fast they can do, Pak Sandes?
So I think for now, I believe from the ecosystem point of view, we would see in 2022 large scale deployments of ORAN, especially in Europe. And if an operator wants to deploy it, I think some of the challenges that we have, or rather some of the considerations that we have to have, is that the organization first have to be aligned to the goal. So what I mean by that is that um, we need, so most of our current teams are not very aware of these cloud technologies. Okay, we need to understand these cloud technologies, especially even on the RAN side. Maybe some of the core teams already know, because most of the core networks is already cloudified, running on as CNFs and VNFs, but the RAN teams doesn't know. Secondly, we also have to establish clear goals of what we want to achieve out of it. I think it's not a distant dream for the networks to turn completely open. I would say the best way to do that is start with trials. RIC I think is very important, because RIC is something that you can trial right away in your network. For RIC, you don't have to implement an ORAN compliant or anything. RIC work with the existing infrastructure also. So, for example, if you want to see how this is going to work, you could trial a RIC first. Okay, and then with RIC in place, you could try some lab setup with the CU and DU and virtualized everything on an open interface. Everything working, we could take it to field, and then it could take to mass deployment. I feel that this whole process would take about 2 years to go through if the operator has to start now. But there are a lot of operators who have already started this journey long back. There are many of them who are already in this journey ahead, and like we would be seeing a lot of implementations, especially in Europe. And what I have seen is in most RFPs nowadays, operators demand that even if they're deploying vendor specific hardware right now, they demand that it should be coming from it should be open front haul compliant. That means that they would deploy the classical RAN right now, but since it's open front haul compliant, they would replace later on or upgrade it with some ORAN compliant hardware and slowly take off. I think in the near future, it would, I mean, it would start mass deployments, and I think in very soon we would have everything open and virtualized. Yeah? Because it has to be, otherwise there is no way for the operators to make more out of their investments.
Yeah, thank you so much, Pak Sandes. I think very clear the explanation. Is there any question? Yes, please, Mas Lutfi, you can open your mic.
Okay, okay. Okay. Hello, Pak Sandes.
Hi, Pak.
Okay. Okay. My name is Lutfi. The firstly, thank you for good sharing. Okay, I am still learning in this area. So, I have two questions. Okay, the first thing, everyone know VMware one of the best cloud company, and
Yes.
then OpenStack a good choice for the open source technology,
Yeah.
and those most of being used. Okay, so the question is it possible to running together VMware OpenStack?
Yes. Yes.
And maybe you have experience in commercial or not? Okay, because today many people consider to choose open source technology. Okay.
Yes. Yeah. VMware does
This
support OpenStack, and you can implement OpenStack on VMware. That is possible. Right?
okay
That's
possible,
possible.
Pak.
Yeah, that's possible.
Okay, okay.
So the beauty of VMware is it's very flexible. That's what I. So you can have our own hypervisor, or you can take OpenStack or other. So that is completely possible. Pagoni, actually, you have sent me this list of questions, right? So maybe I think we can go through those because some of the questions might get addressed.
Okay, Pak.
Okay.
So
So let me go through these. Yeah. So I've already documented here. So
yes, Pak, please, Pak.
how future RAN technology architecture looks like. As I said just now, yeah, for me the future is open and cloud native. So open vRAN, which is what I'm doing. I think this is the future, and why I see this is because unless this is done, there is no way operators would be able to utilize their investment in RAN to make more revenue out of their investment. RAN is about 70% of what the operator spends on their capex. So it has to have these innovations and new technologies. Only
Understand.
then we would have end-to-end network slicing type of use cases, which could give a lot more revenue than selling services like data plans. This is not going to work. Okay. The second question was why we need cloud native and vRAN. What if we stay like what we have right now? So classical RAN, the problem is that it is not agile. As I said, right, we have seen this, that in many cases when the 4G came in the first place, it was missing basic counters that we had in 2G. And it took almost 6 to 8 months for these counters to come in LT. This was really frustrating. I mean, being an engineer, it was frustrating. Imagine what frustration the operators would have, right?
Correct.
So they have upgraded two technologies, but they have missed on a lot of few basic features. There was no mechanism available for us to quickly catch up to this, and that is the problem of classical RAN, because it is built on a purpose built hardware on a closed software. Once it is cloudified, open, this would have we could be able to run it on purpose built customize of the shelf, not customize, sorry, commercial off the shelf hardware. And that with that we'll have a lot of choice. We have seen that with the supply chain challenges, everything got delayed recently in the pandemic, right? This
Yep.
wouldn't have been the case when we would have option of running any app on a commercial off the shelves. So these are some of the things that I think are driving the cloudification of RAN. And coupled with that is the agility and programmability that is going to add, because again, this is what is needed for us to drive more revenue out of 5G.
Yeah. Pak Sandes, by the way, so we know, right? Like Nokia and Ericsson also join in Open RAN. So
Yes.
what is their business with Open RAN, Pak Sandes? What is the roadmap they are joining Open RAN community here? Do you
Yeah.
know
So
something? Hmm.
yeah. Especially I know more about Nokia's Open RAN because I was there. I worked with Nokia for a long time, and I could see it from inside and outside. With Ericsson, maybe it's not. I don't have maybe complete visibility. So with Nokia has realized that open architecture is going to be the future, and they have publicly said that multiple times that they're going to be fully open RAN compliant. And I think that's a fantastic move because That is where the industry is going to. And and an established vendor like Nokia coming to play would ensure that we have very high quality CU and DU software available. We'd have very high quality RUs available because they are very good in that. Okay, they have established themselves in that. But now we will be able to run Nokia CU software on any other hardware, on any cloud.
Oh, really,
That
Pak?
is yeah, that is what is going to happen. That is what is going to happen. So they would have their CU software, and we would be able to run that on any other cloud or any other hardware.
Wow, it's
And
very fantastic.
that's very interesting, right? Because I have seen Nokia software is very stable. It's very nice, and that's why it would add a lot to this ecosystem. They have a lot of SON use cases, right? And they're going to migrate probably that to apps on the apps X app or R app stores. Then all of this would be available for us to download and use. We into the RIC. They would also actively contribute to the RIC. They would have probably their own RIC, and that is what the beauty is. Right now you would be able to choose. If you think that Nokia CU is the best suited software for your network, you could download that and use that CU. And now imagine that in the current network, when you have to swap vendors,
Correct.
it takes forever. But in cloudified network, it won't take any time. You would
Yes,
have probably two CU softwares running simultaneously, and you could switch
switch everything.
immediately to the next one.
Yes,
Yeah,
yes.
the runtime swap. So that
So,
would create a lot of pressure also on all of the ecosystem vendors to create best quality softwares. Yeah.
okay. So, maybe so in the future there is possibility like Ericsson, Nokia, and Huawei just sending their run software like what they are doing in the core network, ya, Pak, ya? So like,
Yeah, I see Nokia already doing that. Already have clear intent. I'm not sure what Ericsson is going, because I have not worked very
yes, yes,
closely
yes,
with
yes.
Ericsson. Huawei, I'm not sure. Huawei, I don't think is very pro to open
Yeah,
standards.
I
Yeah.
think Huawei still not yet joined, if I'm not mistaken.
Yeah.
Mm,
And
understood.
Samsung is very pro to open. So right now you can run Samsung CU software on any other hardware. That is possible on any cloud. Yeah. I think we already addressed just now these two topics. I think microservices I covered,
Yes, yes.
and we just talk about Nokia. So Nokia has a cloud RAN for sure, and Nokia's cloud RAN is currently closed, but they will go to Open RAN that they have mentioned, and I think it's a very exciting news. I think everybody would be happy. And again, you had this question that comparing to Nokia's and the Open vRAN, who is more advanced? I don't think that really would be would be like a competition to so to say. It's about adapting the standards. Nokia has already said that they're going to be open and compliant, which is fantastic. And as I said, they would contribute a lot to the open RAN ecosystem. Uh, uh, from the cost perspective, I think in the short term, it would be expensive to deploy ORAN. And the reason is because you would need a lot of testing to be done. But in the long run, ORAN will be far cheaper to deploy. There was a question of how does the future network operator look like? So for me, in the future, network would run as a service, wherein you
So,
would be runtime able to configure. So service for enterprises. So for example, Tesla wants to have a dedicated network all across the globe for its cars. Right now, they cannot do that because they have to depend on the operators and then the operators' capability to do that. When we would be able to slice the network for them, they could have their own network running through all of these operators, and they could configure that network on the fly through the APIs that are available. That is at least what I envision the future of the network would look like. And for that to happen, it has to be cloudified, it has to be open, and it has to be programmable.
great, Pak.
One question you had was regarding the Amazon Dish network. Yeah. So that Dish is building their own network on top of Amazon infrastructure. And how does the network look like? Okay, so Dish is the world's first 100% cloud native 5G network. It's a greenfield network. They have everything running on cloud, from the core to the edge. Everything is run on the cloud. So let's look at the architecture. How does it look like? Yeah, so their regional data centers have the core functions running, and they have this breakout edge data centers, as they call, where they run the CU software. And then the CU software, which is running on their virtual private cloud in the breakout edge data centers of Amazon, are connected through a pass-through edge data center to the sites, because this would be more distributed. And their DU is distributed. So their DU is running on-prem, distributed across the network, and then it is connected to the cell site. Now, one question to everyone: guess who's their platform partner to manage their network from the core to the edge and even to the distribution centers? Any guess?
Rakuten, Pak.
It's VMware, Pak. So it's VMware who's running end to end.
Understood. Yes.
So, and they are so impressed with our platform that they have ensured that every vendor that is coming has to comply with our platform. Even they're trying our rig.
I have a question here, Pak Sandes.
Yeah.
So, for example, in the core, network, we still not yet supported for microservice platform. So, in this case, how the solution from VMware, Pak Sandes? So the platform will be same with VMware with one version, or special for monolithic software support and microservice, it will be in the different platform, Pak Sandes?
So we call it telco cloud platform, and then for RAN we have telco cloud platform for RAN, which is RAN optimized. But you could have VNFs where you could run these maybe non-microservice type of non-containerized applications. They could still run on the same VMware platform on VNS, and you could have CNFs which would run the containerized microservices application, and it still runs on the same platform. And I think that is the beauty of it. Yeah.
Understood.
Yeah.
Because in my current strategy, Pak, for different platform, for monolithic software, we are using VMware in the core. But for the microservice one, we are using Robin. So we are still using different platform.
Yeah. I know that. So this has so I think it's also going to be interesting because there will be a lot of platform players to this ecosystem. And I think connected to this, you asked the question that compared to other vendors, Cisco, Red Hat, Robin, what is VMware strong point? And I think I highlighted it, right? Multi-cloud is our strong point. We could run everything end to end. And this is not what I say. It's based on the industry research. So ABI Research ranked VMware as the leading telco cloud platform in the industry. So it's an overall leader. It's the top innovator and top implementer in compared to all the others. So Red Hat, Nokia, AWS, Google, and Wind River. Compared to everything, we are the overall leader in this space. And I see that it's because they have a very strong background into virtualization. They understand the software-defined data centers very well. That's what their journey have been. Yeah. So yeah, that's where VMware is. And maybe at this point, I would like to take 2 minutes just to say that if you're working for any operator and you would like to further, because I know that most of the RAN teams are not aware about these cloud technologies. Today we just touch based on what those word means and what those technology means. But if you want to understand in detail the cloud native technologies, please feel free to reach out to me. I'll be more than happy to come join and connect. Try to find out what can be done together. If there are people from other companies who wants to connect, where we could you see a potential to work together, more than happy to connect. Okay, so feel free. Or if you want to learn more about overall about these technologies, you can reach out to me on LinkedIn. I'll be more than happy to share.
Yeah. Maybe is there any another question from all the participants? We have maybe 5 minutes left to ask a question. Please, you can open your mic. Okay. Okay, Pak Sandes, I think a very interesting topic that we are discussing today. So we gain a lot of knowledge from you. So thank you so much, Pak Sandes, for your time. Really appreciate it. So hopefully we can hold another session regarding virtualization. About for the next step, the next step of cloud and RAN virtualization. Hopefully, Pak Sandes.
Yes, sure, Pa. In fact, we can have a separate session on just on the platform details. Yeah? What does it come and to the platform? What are this? And maybe I can ask some of my VMware colleagues to join who are experts in the platform side, talk about virtualization in detail.
Yeah, Pak Sandes, maybe last suggestion for you from you. You already having a very so many experience working as a RAN engineer.
Yeah.
So now you are shifting your career as more to IT. What is your suggestion for us that still working for RAN to prepare ourselves to welcoming the future RAN technology, Pak Sandes?
Yes, I think very good question, Goni. I mean, even I wanted to talk about it, even if you hadn't asked. So I think the way I look at it is that the future is going to be open and cloud native. So there are two comprehensions for everyone in this regard. So one is that people are, especially on the RF side, might be a bit afraid that is the automation going to reduce the number of jobs, and what do I need to do to ensure I remain employable in this field? Yeah. So I would answer both of the question. I don't think the automation is going to impact the jobs. What the automation is going to do is it's going to make us capable of handling far complicated and far bigger network than what we are currently handling. That is what automation is going to do. So it's going to augment us. Now, secondly, coming to the second part, that what you asked, that what we should do, I think we all should learn about cloud technologies. That is, I think, a must. That's where the industry is going, and we all should have two. Apart from the cloud skills, we should have two other skills as RAN experts. One is that we need to understand data analytics, and we need to understand AI/ML. So this is and with that comes programming. Yeah, so we should have coding skills for sure, but with that we should be able to also have data analytics skills as well as AI/ML skills. This is something that is going to become a usual day-to-day in our life very soon. We would have we would be I see the RAN engineers of the future coding their own algorithms based on the AI/ML workflows that are available, and this is something that would make you unique in this field. Plus, it also would open up a lot of opportunities for you to be entrepreneurs, because there will be a lot of XApps that you could code, you could sell, and I think that this is a big opportunity for all of us.
Yeah, thank you so much, Pak Sandes, for your suggestion. I hope we can prepare ourselves as much as we can, because tomorrow become changing very fast, ya, Pak.
Yeah, exactly.
Yeah.
I think it's going to change very soon. I'm very fast, very soon. So we should we should adapt very, very quickly. Yeah.
Yeah, Pak.
If you don't mind, shall I capture the screenshot of the
Yes, Pak.
participants? Yeah.
Yes, sure, sure.
I'll
Okay,
just,
maybe our presentation will be end soon, so
yeah.
I'm recommend for all of the participant can open the camera so we can take the picture together. Yeah. So I'm waiting, still waiting. Okay, hopefully all of the member here can participate to open the camera so we can take the photo together. Okay. Okay, that's it. That can be participant. Okay, so let me capture. 1, 2, 3.
This one more
Okay.
screen. Yeah.
Next page maybe. Stay. 1, 2, 3. Okay. Okay, Pak Sandes, I have a capture.
Yeah,
Maybe
thank you.
yeah, I will share
Yes.
the meeting today.
Yes.
Okay,
Sure.
maybe I think this we are already in the end of the session for today. I really appreciate for Pak Sandes' time and all of the effort for preparing the slide and then doing sharing session for us today. So thank you so much, Pak Sandes. I hope this is not only one time. I hope we can do for another time with different topic for sure.
Sure. Sure.
And also really appreciate for NETCO team that already set up this session. This is very useful session for all of us, I believe, because we gain a lot of knowledge regarding Open RAN and cloud. It's very nice session and nice discussion today. So I think we already in the end of the session. I'm sorry if I have a mistake. Maybe I cannot cover all of the question from all of the people because of we are limiting time. So maybe see you in the next session. Yeah, thank you so much, everybody. Thank you, Pak Sandes.
Thanks. Thank you, everyone. Thanks, Pak.
Thank you, Mr. Sandes.
Thank you, Pak Krishna.
Bye.
Thanks. Bye-bye.